Oh, you can go ahead, Katie.
Hey everyone, today we'll be presenting on organic wastewater contaminants. So what is wastewater? Wastewater is any water that has been contaminated by human use, and it's usually gray water and black water. And so gray water is all like showers, baths, whereas black water is going to be your toilets and your sinks. And wastewater is industrial, commercial, agricultural, as well as domestic, which would be like our households. So wastewater, most of the time, is put back into our environment without any kind of treatment. And I saw that these numbers could be as high as 80% of all wastewater is never treated by the treatment plants. But the kinds that are treated by the treatment plants, like the one near the Greenway and Boone, they're either put back into surface waters or they're reused some other way. Wastewater contaminants can either be synthetic chemicals or nitrogen and phosphorus, which comes from human waste, food, and some of our soaps and detergents. And this excess phosphorus and nitrogen will cause a problem because it supports the growth of algae, which isn't always good because too much algae will overwhelm the ecosystem. And so, as I mentioned before, because there's too much algae, the oxygen levels are going to decrease for the fish and the other aquatic animals, and they will die because of that. So, some more ecological impacts from these bad chemicals in our water include all of these studies that I found, and there's a pretty good range. There's a lot of different countries like Germany, Sweden, Italy, the US, and I just want to take a look at a couple of them to emphasize the risks these compounds are putting for our wildlife. So the first study I have is by Kolek et al., and they look at fathead minnows in Nebraska, and they're looking at how these contaminants are affecting the hepatic gene expression as well as their mortality rate. So what they did is they took three different sections of the water. There's the Norfolk wastewater plant. There's Sand Creek and then Fisher Creek. Sand Creek is known to be impacted by runoff from agriculture. And so the results from this study was that they found that the fish exposed to the sediments near the wastewater plant as well as the agriculture runoff had significantly higher levels of the gene expression. And the hepatic gene is related to the liver, by the way. And the fish immediately downstream of the wastewater treatment plant had the highest mortality compared to the other locations. So the study found that exposure to these chemicals in our water is definitely killing the fish, but it's also runoff from agriculture. And then another case is by Hoger et al., which is a German study that focuses on the concern of pharmaceuticals being found in our water. So this study investigated a non-steroidal inflammatory drug called diclofenac. It's used to treat pain and migraines and arthritis. And they specifically looked at brown trout, which is native to the German creeks that they did the study on. This was in Germany. And the fish that were exposed to this drug had reduced hematocrit levels, which is the volume of the red blood cells compared to the total volume of blood. So of course, if the volume of red blood cells is significantly less. That's not a good thing. And they noticed that um, the longer these trout were exposed to the drug in the water, the worse it was for them. They got things like um, problems with their gills, with their kidneys, with their liver, just all sorts of horrible things were happening to these brown trout just after 21 days of being exposed. So they definitely found that these uh, contaminants in the water were affecting the trout.
Okay, so as us humans and as most organisms, we rely every day on basic essentials, and one of our most important essentials is water. However, sometimes the water sources we have may not always be the safest, even if it's from a water bottle. Companies and industries are heavily regulated on chemical and other uses of hazardous waste that can be very dangerous to our general water source to the public. And this can also be applied to any piping that goes around your house. And something that we must consider is that a lot of the chemicals that they also use also won't be stopped by any basic filtering that your house can do. More than 2 million people around the world die each year from unsafe drinking water. And something that we see here is that even though in the US there's not a lot of deaths, we can also log several of the deaths that happen around the world due to bad filtration of the water. So in countries like Africa, a bit of India, and I believe a large chunk of China suffer from water that can be traced back to fecal matter. I know that sounds very disturbing, but that number allocates to over 26% of the world's population. Lead contamination. This is one of the most common contaminations that happens in the US and around the world that relates to bad piping. This can be just general old piping that has not been renovated by the city, or this could be bad piping that you bought at a store like Home Depot or Lowe's that isn't properly treated for running water. This can lead to salinity in the water. This can lead to unnecessary chemicals in the water. This can also alternate water temperatures and can also damage your pipes way beyond from what they need to have water in. And as of right now in the United States, we have one thing above else that has been affected by lead poisoning, and it's in those states is Washington, California, Arizona, Florida, New Jersey, Pennsylvania, and Georgia. And as of right now, they've logged over 15% of the United States lead cases where most people don't die, but these complications can lead to very severe alterations later on in your life from things from heart disease to blood poisoning and complications in birth and also neurological memory. Flint, Michigan water crisis. This is one of the biggest ongoing cases of lead poisoning in water. It started in 2014 when Flint, Michigan switched from the Detroit water system to their own personal river water system, and the government the governor there accidentally contaminated set water through what they thought was just standard filtration. And the first known case of Legionnaire's disease was reported at an outbreak that ultimately killed over 12 people and got 87 people severely sick in Genesee County. In 2015, the government declares a state of emergency for the town, in which it literally took them over the course of this year. I believe it was over 13 months before the general public was warned about this scenario. This water, bear in mind, was yellow, very basic in its acidity level. Its pH, I believe, was sitting at around 16, 17. That and like that's very unsafe considering your water needs to be like pH 7 through 8. Um, it was a period about 8 months where people were officially kept blind about the situation right before the governor actually declares to the people what is going on. And unfortunately enough, it wasn't until December 10th of 2016 that the U.S. Senate took notice of the problem and approved a bill allocating $100 million in funds to clean and repair Flint's water system. And as of today, the water has somewhat improved, but it's going to take a bit more time than just a couple of years of recovering before all that lead is filtered because it was that severe. So this kind of leads into something that a lot of us don't really think about when taking care of like chemicals and stuff. It's house water chemical contamination. So things in your household that include such as detergents, soap, bleach, medicines, and things like oils can ruin hundreds of thousands of gallons of safe drinking water. So a lot of the times having a sink or some kind of like plumbing that's directly connected to a disposal might sound convenient, but at the end of the day, that ruins hundreds of thousands of gallons of water. You might be able to get away with things like soaps and detergents, but leading into the harsher chemicals like bleach and just all these like really strong just cleaning detergents like Windex and stuff just is completely horrible for your plumbing and yourself. Because if you could, like what we talked about earlier with plumbing corrosion and stuff, a lot of these chemicals ruin the plumbing and wear it down very severely. And this is taken back all the way to the water treatment plants. And even though at the water treatment plants we see that the water 99% of the time is clearly processed, your chemicals are getting mixed with everybody else's water. And this is just thousands of more gallons of water that needs to be filtered every day, considering the average human goes through a minimum of 700 gallons of water across one household per day. And more the common things that you shouldn't be pouring into water are from across this list. You have paints, oils, for any form of alcohol, any powdery substances should not be drained because they not only clog up, they scratch up against the piping, which cause even more corrosion. And two of the biggest ones that I want to cover real quickly are grease and car oil. These are not in a way a liquid that mixes in well with water. They literally stay separate from water. And what that might sound good, it literally leaves chunks of oil and grease within the water that are very hard to filter. Like it takes hours to make sure that water is properly filtered. Outbreaks in the U.S. and some of the most common ones we see are Giardia, Leonia, norovirus, and the rest from this list. And you can click on all of these. These are all CDC links that you can click and review and see what the side effects, conditionings, and long-term effects are if you ever been affected by these. And almost every year we see thousands of cases in the U.S. From that get affected by these outbreaks. And as I said earlier, not many people die from these outbreaks, but the problem is the long-term side effects that you get from these outbreaks. And the most people susceptible to these are infants, young children, pregnant women, elderly, which immune systems might have been compromised due to any of these conditions. Here we go. We can review this later. This is actually a death toll counter that I have found that actively changes by the minute. Ooh, as of right now, when I checked it this morning, it was still over 2 million. And since last night, when I checked it again, we have raised over 2,000 deaths in water pollution contamination. Ian, here you go.
Alrighty, so let's talk about some economic significance. All right, water left untreated in developing countries is discharged directly into the environment. Costs are generated and or potential benefits are lost. So this can affect a lot of things that use water. We're talking industrial production, fisheries, or aquaculture. And tourism is a big one that can also be impacted. And all of these systems can be monetized and have market value to a degree. Tourism in some countries is the main source of income, such as the Bahamas. So wastewater can be a real issue. All right, some more on economic impact. The global economic losses associated with inadequate water supply and sanitation is estimated at $260 billion annually, and that's in US dollars. Wastewater treatment plants in the United States generate approximately 7 million dry tons of biosolids each year. And since biosolids are such rich in plant nutrients, farmers and landscapers and homeowners use about 50% of the annual production of biosolids as fertilizer for plants. And these biosolids sometimes have trace amounts of organic pollutants, and these pollutants can have very trace amounts within them, and it can be absorbed into the soil, into the plants, and possibly leading to livestock eating those plants. So with this, with the removing wastewater here, we're talking about removing 5 pharmaceutical and personal care products from wastewaters, and this is in euros per kilogram. And I couldn't figure out how to convert that. But so basically on the left, we're looking at non-sensitive body waters compared to sensitive body waters below it. And I'm going to try to say this word, but I'm going to botch it. I know it's birth control, but it's ethinylestradiol. So that has the highest cost for removal from both non and sensitive bodies of water. And just some other ones that are in here is we have a non-steroidal anti-inflammatory drug. Galaxolide is a synthetic musk smell for fragrances. And then sulfamethoxyl is an antibiotic used for UTI, bronchitis, gram-negative, and gram-positive bacteria like E. coli. So those are pretty common, and I'm pretty sure everyone has used all of those. Okay. So some more economic costs of removal waste. Reverse osmosis is pretty common. It's used in water treatment and oil and gas industries. It's only applicable to remove low molecular weight chlorinated hydrocarbons. Then we also have thermal distillation, which could be used. And costs associated with these technologies are several times higher than that of reverse osmosis because of the high energy output. And reverse osmosis uses membrane technology to help remove low molecular weight hydrocarbons, and the desalinated water typically costs about 200 acres per foot. It's double that of recycling wastewater, according to a 2013 study from the State Department of Water Resources. Okay, so this next graph that I pulled, it's basically on the social significance, and it's showing the number of people in millions living alongside polluted rivers and 10 major river basins. So at the top we have the Ganges, and it basically has a projected number of people living, and then also people in 2000. So the lower one, the smaller graph at the Ganges, it's about 450 million in the year 2000, and then it projected growth in the year 2050 jumps to 825 million. So that's pretty interesting, I think. Okay. Over half of the world's hospital beds are occupied by people suffering from diseases caused by contaminated water, which is absolutely mind-boggling. In many developing countries, an estimated 1.8 million children under 5 years old died due to water-related issues. And we talked about that on the other slides too, just to tie back a little bit. So some more on social significance. According to the Fourth World Water Development Report, only 20% of globally produced wastewater receives proper treatment. This typically depends on the income level of the country. In high-income countries such as the USA, the treatment capacity reaches up to 70% of the generated wastewater compared to 8% in low-income countries such as Bangladesh. Okay, so here's some social significance around the world. In one study I found in Scotland, the discharge of untreated organic waste from salmon production is equivalent to 75% of the pollution discharged by human populations. And in Bangladesh, shrimp aquaculture generates 600 tons of waste per day, according to the SACEP, which means the South Asian Cooperative Environment Program. So both of these lead to devastatingly polluted water. And many low-income countries like Bangladesh don't have the proper infrastructure to maintain such high levels of pollutants, which leads to waterborne illnesses. And many economic and social impacts intertwine and leave lower-income countries set in a catch-22. They can't create infrastructure to manage, and they can't afford not to feed their people or make a living. Alrighty.
Okay, so what have we been doing to try to manage the pollutants in our water? So the first thing is simply pollution prevention, which is just not producing the waste in the first place. By doing this, we'll obviously reduce the amount of toxic waste we generate because it's not being made in the first place. But then there's also efforts being made at our wastewater treatment plants to try and further prevent the contaminants getting into our water, since a lot of that is theirs to deal with. So over at the wastewater treatment plants, they can better maintain their sewer lines to prevent untreated discharge into our waterways, keep the hazardous chemicals out of sewer lines, adopt preventative maintenance programs, and there's many other things the wastewater treatment plants can do. And their states have also been creating these clean water roadmaps that I found. There's one that I linked below in particular to Minnesota, and they're basically just these plans that say how they're going to start controlling what goes into our water. They say like what percentage of waters have certain contaminants and what is like their main focus, like the different bodies of water. And these are all good, but pollution prevention is kind of hard to enforce. Not many people are going to listen. The wastewater treatment operation plan is good, but it'd be better if we could just keep these out of the water overall, so it never even reaches the wastewater plant. And then the implementing a clean water roadmap is actually really good. I thought that was a great way to handle things, to have like something written out and see how we're working towards this goal.
Yeah, something I'd like to add real quickly, it's with hazardous chemicals that can be going back into our sewer lines, it's being acknowledgeable and self-aware. Many of the things that are in your household can go down your sewage line. However, it's just insignificant things that you wouldn't recognize that can do the most harm to water and to the people around you, because with some towns, they might not even have a centralized water filtration system. They just have a smaller, not as powerful one, as might per se. And you have to recognize that things like oil and medicine will not filter through that properly. They're just going to go right through it, and they're going to go right back to your lines, and those are the kind of things that can kill a human being, unlike just basic alkalinity and like traces of lead that might not do much to you. Things like oil, like the like just drinking like a cup of oil will kill you. And it's like traces of oil can do serious harm to brain and nervous systems.
Could you go back just real quick?
Yeah.
And I just wanted to comment on this picture down here. It says PCBs kills communities. And this is a picture taken in a small town in West Virginia. And this is just an example of how runoff can almost permanently contaminate water sources, because this town had a mine shaft that was operating, and I think the government just like really messed up, and there was a big PCB leak. And now all of the water sources around Minden are contaminated, and it's really affecting the children that live there. And it's destroying the community because no one wants to live there, but at the same time, most people can't afford to move. So yeah, if we can stop these chemicals from ever entering the sewer lines or just our water sources, that would be one of the best ways to control this. Some other efforts is to just encourage water conservation measures in the community. So like changing to low flow models with our shower heads and faucets, because if we use less water, we're going to have less chemicals entering the system. And just like doing full loads when you're washing your clothes or your dishwasher, as opposed to only doing like 1 or 2 things at a time, because that wastes water. And then there's other things we could explore, like reusing our wastewater. So like irrigation of crops and pasture land, irrigating golf courses and parks. Now, this kind of concerns me because you'd really want to make sure that this wastewater we're reusing is clean, because if putting these chemicals and harmful organic compounds is bad for aquatic life, I can only imagine it would also be horrible for our land if it wasn't properly treated and cleaned. So while I like the idea of reusing the wastewater, it definitely needs to be clean. And this is a case that I found that I thought was very interesting and a very cool way to start managing these pollutants, which was to use nanoparticles. And this was made in 2014, so it's fairly recent. But these nanoparticles can be used to treat the water more efficiently than what we have been doing. I read in the article that there definitely needs to be more research done, but that these nanoparticles can penetrate deeper and treat the wastewater that conventional technologies could not do. They have higher absorption, interaction, and reaction capabilities. So I think this is a really good option to manage these pollutants, is to bring in these nanoparticles. And you can see in the little diagram in the corner how big they are compared to like a virus and an antibody. And they're also cheaper to use from what I've read.
So here we have our discussion questions. If you all we can talk over this, and if you guys have any extra questions, we can answer all those accordingly. As for now, we have one video that we'd like to go over that will talk about sedimentary, natural resources, and toxic waste products that affect populations every single day. Let me go ahead and find that video for y'all. Is the sound not going through for y'all?
I don't hear anything, man.
Let's see here. I don't 100% know why the sound is not going through. Okay, so we got the video working, and now I'm going to share that for y'all.
Practices are closely tied to the centerpiece of this whole water quality puzzle: pollutants. Some water pollutants are easy to see, like garbage, but the most serious pollution problems aren't as obvious. Sediment, nutrients, chemicals, pathogens. Sediment is simply soil. It's a valuable resource in a farm field or along a stream bank. but it becomes a major problem when it's washed into waterways. At the root of the problem is erosion.
Erosion off of farm fields, construction sites where you don't have proper sediment control structures in place. You can easily have sediment eroded off of those landscape areas. You can have pasture areas that are overgrazed, animal access, cattle access directly to streams. With all of the trampling along a stream corridor, that exposes bare ground, which in turn exposes sediment to erosion. And then along all of our major rivers, if you don't have a lot of vegetation sort of holding the soil in place, stream banks can be a major source of sediment.
Why is soil so damaging when it's in water? It affects everything from the way water looks to what can live in it. Sediment can block sunlight, influencing what types of vegetation and species can thrive in that water. Sediment fills in waterways, affecting transportation and recreation. And sediment can be a carrier for other pollutants, like toxic chemicals, which attach to the sediment, making it a double threat. Next are nutrients, which pose an entirely different problem. Nitrogen and phosphorus are natural components of manure, human sewage, and decaying organic matter like leaves. They're also present in manufactured fertilizers. Nutrients are applied to farm fields to feed crops and to backyard gardens. They're used to green up golf courses and lawns. They become a problem when precipitation washes nutrients off the land and into waterways. Once they're in water, they do what they do on land, enhance plant growth.
When we have too much nitrogen in the water, your water tends to turn green and you get a lot of algae blooms. When those algae blooms finally die and the algae start to decompose, they take up all the oxygen in the water, and so there's a low amount of oxygen in the water, which causes problems for fish and plants because they need that oxygen.
Nutrients aren't just damaging to watery ecosystems, they also pose a real risk to humans. Nitrates, a byproduct of nitrogen, are especially dangerous.
When we have too much nitrogen in drinking water, for instance, babies, maybe infants under 6 months of age, can develop something called blue baby syndrome. And what that is their blood can't carry enough oxygen. And that can cause some health problems. And in fact, we may have older people or people who are in poor health that can also have that problem.
The risk is so serious that the Environmental Protection Agency, EPA, tightly regulates the levels allowed in drinking water. Chemicals are another class of pollutants. Some chemicals commonly used in manufacturing, mercury, PCBs, lead, are toxic to the environment and humans when they reach certain levels. Because of the health risks these chemicals pose, the EPA carefully regulates industrial waste. Special permits govern the disposal of toxic chemicals, but spills, accidents, and improper disposal mean they still get into waterways. The problem isn't just industrial either. Think of the toxins around your own house: cleaners, paint thinners, pesticides, oil. Improper disposal of just 1 gallon of oil can impair 250,000 gallons of water, about the amount of water in this pool. Agriculture also relies heavily on chemicals like herbicides and pesticides. Their application needs to be carefully controlled to prevent contamination of water. The list of chemicals we use every day has grown faster than our knowledge of how they interact with the environment. Emerging contaminants, a buzzword in water circles, looks at chemicals not traditionally tracked like caffeine, over-the-counter drugs, antibiotics, and disinfectants. A study completed by the United States Geological Survey found levels of many of these contaminants in streams across the United States. Now, the real work begins to see what, if any, effects these chemicals have on water quality. Pathogens are probably the most serious threat to our health. Pathogens are disease-causing bacteria and viruses. They can come from human sewage or raw animal waste. If pathogens contaminate water and aren't eliminated during treatment, the tiny organisms can kill.
One of the real risks that anybody faces who treats water, either to drink or as we do, to make in a condition that can be returned to the river so fish and wildlife can use it and so other people can drink it, is killing certain kinds of viral infections or bacteria.
Katie, Ian, do you have anything more to add?
No, I think I'm good, man.
I think I'm good too.
If y'all want to review any of our information, here are our sources. One of our greatest sources that came to our knowledge was the CDC and the EPA. They help us a lot with water control and understanding of what goes into our water. Thank y'all for your time, and I hope to hear y'all in the discussion.